Thank you, Mr. Chairman, and good afternoon to everyone. I'm going to present here some work that we have been performing lastly about endodontic files, and more recently on the possibility of looking for the effects of the heat treatment on these instruments. The background of this problem is that we need to solve a clinical problem using those clinical instruments, and the problem of solution of this clinical problem comes from the complex geometry that we have here, because those canals are really very complex geometry, not only in terms of curvatures, very complex, and in different planes, and in most cases could be also with very accentuated curvatures. This requires the very well-known superelasticity that nickel titanium alloys show, and everyone knows. And we have been working on the problem of this utilization of this nickel titanium endodontic files in a PhD thesis a couple of years ago. And in that study, we have been looking at the problem of rotation flexion, and we identified by that time, as a final part of the study that has been led, that performing the rotation flexion test at different ambient temperatures, we could get something very significantly different in terms of number of cycles to fracture. As a matter of fact, this effect can be noticed also on this representation, where we can see how does R phase begins and ends the formation in cooling and in heating, and we see that the number of cycles to fracture as a function of the temperature where the test is performed follows a very similar trend of that. By the same time, there had been some references in the literature and commercial development of products of this type, speaking about the so-called R-phase treatment by a specific fabricant of endodontic files. And meanwhile, a great number of workers in this field have started feeling interested on the problem of the heat treating the nickel titanium endodontic files. So we followed this trend, and nowadays, this is just one example. There are a lot of situations where people is trying to find out what's going on when you heat treat endodontic files. As a matter of fact, looking at some of this data that is published in the literature, we found out that there were two types of problems. In some situations from our previous experience on the field, we were not feeling very comfortable on the transformation temperatures that were shown in publications, and on the other hand, mostly for some situations of high temperature heat treatment, they were clearly putting the material in a situation that would not eventually be the most interesting for the application. At the same time, we are also handling some experiments where we had been looking at two types of endodontic files, where we were finding a general geometry for the longitudinal aspect of the file, but with different cross-sections, geometry cross-sections of the files. And this has put several interesting problems related with this study. First point that we have been looking at was the transformation temperatures and how do they change as a function of heat treatment temperatures. And you see here that starting from the red curve that is the as received endodontic file, we have with heat treatments of 250, 300, 350, 400, and 450, we have a clear shift of the transformation temperatures, and we have dedicated some attention to this. So we started looking, for example, with the endodontic file known as MTWO, and here you find the variation of the heat, the transformation temperatures as a function of the heat treatment, and you see the as received, then 250, 300, 350, 400, and we have followed the same trend for the other two situations that we have been dealing, the K3 and K3. That's K3 and K3XF is exactly the same geometry. The difference is that the K3XF is reported by the fabricant as being one of the material with the so-called R-phase treatment. We fixed our attention for the reason of the in-service temperature of the material, the oral temperature, to be mostly possible austenitical. And we fixed our attention on two situations in terms of heat treatment, 350 and 400 degrees. And we did it for this series, and in all the situations we noticed two very clear aspects, very well known, is that the transformation temperature has shifted to higher temperatures, and this effect is much more notorious when we look to the transformations on the heating part of the material. And this happens the same way with the K3XF. We also have performed X-ray diffraction to control which phases are present in the different situations, and we may find that for the K3-5 we find out that making the heat treatment either at 350 or 400 degrees, we already find very clear evidence of the presence of R phase, and the same happens for the K3XF and for the M2, where there is a very significant evidence of the presence of the R phase. But I should also call your attention to another aspect. That is, it's more noticeable, but also possible to be identified on the other ones. More noticeable on the K3XF, the presence of Ni40I3, that is a very well-known precipitate appearing with the lower temperatures aging for this type of materials. We also have performed a series of assessing the capability of this material to respond as a function of the heat treatment to different kind of tests that could monitor in-service behavior. And in this respect, the results that I'm going to show you clearly show that we need to perform more intense work in terms of statistical representativity, because here I'm showing you just two tests for each situation. Even so, as you may see, it was a lot of tests, but statistically speaking, it's really very little to be done, still to be done. In some situations, we may find that we could guess a general trend for the way things go as a function of the heat treatment, but in other situations there is non-clear evidence of what is the real trend, and most of all it's a problem of statistical representativity of the data that we have performed. So here for the other type of information, the torsion angle and the non-recoverable for each type of alloy. And here, as a resume of the tests, we may see an interesting feature is that for the M2 file, it looks like that heat treatments do not change a lot, at least those that we studied, the behavior in terms of those tests that we have looked at. Although in the K3, the things look like there are eventually significant changes, but once again with K3XF, things do not change a lot. That could be understood as a result of the fact that K3 is not heat treated and K3XF is heat treated. So we have been looking at these results, but we are expecting to perform them more extensively in terms of statistical representativity. And we have also looking at the phases that are present when we are putting the material in the working condition for the rotation flexion. As a matter of fact, we tested the material not in rotation flexion, but in flexion imposed by a constant curvature radius with a curved tube, glass tube, using synchrotron radiation, and we could identify that only R phase or austenite were present, and we could not identify the presence of R phase. It was only martensite that was present, and austenite. And the other interesting feature, maybe see here, you can clearly see that non-bent file, we only see the austenite, while for the bent file, or for the part of the file that is bent, we can clearly distinguish the presence of the martensite and no evidence or not clear evidence of R phase. But also another interesting feature is that this M2 endodontic file has an almost rectangular cross-section, and this means that if we look here, we can see that it's very different when the file is being bent along this direction compared to being bent along this direction. And we clearly identified this geometrical feature on the way that the intensity of the martensite peak versus the intensity of the background of the diffraction pattern that we took. And you see that when the background goes high, that means we are looking through the thinner part of this cross-section. We have, when it goes high, we have practically no martensite intensity peaks. And when we go down in the background, we have a high intensity of the martensite peak. So, as a conclusion, we should say that the problem of the heat treatments for endodontic files is still something very important to be looked at. We have the feeling that some temperatures that most workers are speaking of, above 450, should not at all be in testing temperatures for these instruments, because they would really push the transformation temperatures so high that in the in-service temperature they would not be austenitic, so not super elastic. And we also consider that there are interesting features to be looked at, and during the session this morning, several references to that, and also in the literature, what is the role of the martensite for the behavior during fatigue in service of this type of instruments. So that's what I was intending to present as a result of these studies and knowledge of the findings, and I'm open to your questions.